Now that we understand the relationship between pressure and height, we can look at the change in atmospheric pressure with height on a graph. In this graph, we've plotted the atmospheric pressure against the altitude or height. So we see from this graph that when the altitude is low, we are close to the Earth. And here at the low altitude, close to the Earth's surface, the pressure is high. On the other hand, as the altitude increases and we get to, for example, the height of the top of a mountain, we see that as we've got further away from the Earth's surface, the pressure has decreased. Now let's talk about what happens to an object as it moves through the atmosphere. Well, we know that any container with gas inside will have an overall outwards force normal to its walls, and this is due to the collisions of the particles with the walls. But we also know that generally with a box we will have gas particles outside of the container in the air. Now when these outside particles collide with the wall, they're coming from the other direction, so instead of pushing the wall outwards, they push the wall inwards. So these particles will collide with the container walls and produce a force that pushes the walls inwards. So generally we have both inwards and outwards forces acting on the container. And what's really interesting to note here is that the outwards force on the wall and the inwards force on the wall need to be the same size. Otherwise the wall would be moving because there would be a net force on it. Now that we understand this, let's imagine what happens when a helium balloon floats up into the atmosphere.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.